So in chapter 3, we're going to look at relationships between quantitative variables. And so we're going to use this mainly using scatter plots. And so when we're using quantitative variables, we're looking at a response variable, which is a variable that's going to measure the outcome. And then we have the explanatory variable, which may help explain or influences changes in that response variable. So we're going to look at a relationship between these. And when we talk about the relationship between these, we're talking about their association. Because we've talked before that we can't really say that there's any sort of a causation, but we can say that there might be a relationship between these variables. And so for relationship, we say there's an association. So identify the explanatory and response variables in each setting. So how does drinking beer affect the level of alcohol in our blood? The legal limit for drinking in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol levels. So our explanatory variable is what we're using to affect another variable. So what we're looking to affect is that response variable. So what we're measuring is blood alcohol levels. That's a response variable. And what we're using to affect those or influence the blood alcohol levels is beer. And not just beer, but we're measuring it by numbers of cans of beer. Okay, so for our next problem, we have the National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using the amount of debt and income to explain stress caused by college debt. So we're trying to figure out what's causing this stress. So response variable is stress. We're probably measuring that stress. And we're looking at two different things that influence that. And that would be income and debt. Because if you have a lot of debt but a high income, your stress level may be different than if you have a low income and a big amount of debt. So they're looking at the relationship between income and debt and how that may reflect on stress. And so for our last one, Julie wants to know if she can predict a student's weight from his or her height, because information about height is easier to obtain than information about weight. So we're trying to predict weight. So that's a response variable from a person's height. So we're using height and see how that may influence weight. And so that's our response and explanatory variables. Okay, so like I said earlier, we're going to use scatter plots to graph our data and look at the relationship between them. For categorical variables, we use two-way tables. And for quantitative variables, we're using the scatter plot. So all of our data will be quantitative. Our explanatory variables should always be on our x-axis. So when we're looking at our graph, this is our explanatory. And then our response variable should be on our y-axis. And this goes along with everything we learn in algebra, where our independent variable is down here, and then our dependent variable is here, because we're thinking that this All these values depend on what's happening down here with that explanatory value. So when we're interpreting scatter plots, which is all we're going to start working on today, is we're going to start looking at four main things. We're going to look at the direction of the scatter plot. And so when we talk about direction, we're looking at a positive association, which means that in general, our dots tend to be going up as we move to the right. How we explain that, or how we interpret that, as the explanatory variable increases, so does the response variable. Now with negative association, this is going to go down. So as that explanatory variable increases, the response variable is going to decrease. So as my dots move forward to the right, they're moving down. So as my explanatory increases, these response variables are decreasing. And so when they're asking you for the direction and explain what's going on, those are the sort of things that we're looking for. So our next thing is it linear or is it curved? So that's our form, linear or curved. So if it looks pretty linear going up, pretty linear going down, that'd be your linear. But some of them may curve or curve like that. And so we're looking for that because the things that we're going to use in this chapter only work if our form is linear. So if you don't check, then everything that you do may be for naught. You're wasting your time if you don't actually graph your scatter plot and you look, is it linear or not? Our next thing is strength. So how close do the points come to forming a straight line? So everything I've drawn so far actually comes really close, but most scatter plots truly look like this. And the closer they are to forming a straight line or a continuous curve means that it's going to have more strength. The more spread apart they are, the less strength that it has. So words that we tend to use with strength is strong, moderate, or weak. And we use those in regards to direction. So we may have a strong positive association, or a moderate negative association, or a weak positive association. And so those are ones that we kind of pair up. And then we also want to look for anything that's going to skew our data a little bit, like outliers and influential points. And the difference between outliers and influential points, an influential point is a type of outlier, but in general, when we're looking for outliers, we're looking for anything that is really way above or below all the other groupings. So if I'm looking right here at this red thing, but I had a point way down here, that would be an outlier. But if I'm looking at this one and I have a point way over here to the left, side to side, that would be an influential point. And it's influential in regards with the math that we're going to be doing later on. Okay, so let's go ahead and analyze some scatter plots. Can you tell a person's age from a blood test? So this has a blood measurement, and this has our age. So first, let's go ahead and look at the direction. And it definitely looks like it's going down. So this is a negative association. And I can actually interpret that as blood measurements increase, the age decreases. Okay, the next thing we look at is form. And I don't see much of a curve to it, so it seems pretty linear. Our next thing is strength. So there's kind of a line there to give you an idea of the strength, and they're not all that close to a line, but they're not really spread out either. So I would call this a moderate strength. And remember that we tend to pair that up with our association. So this is really a moderate, negative, linear association. And then any outliers or influential points, it doesn't look like there's anything just really popping out. So if I were to make my final description here, I would say that this is a moderate, linear, or a moderately negative linear association. And that'd be my final description. So when we look at this next graph right here, we can definitely tell that the trend is going up. There's not as many dots as there was in the last one. So they look more spread apart because there's not as many dots, but that's okay. So this is definitely a positive association. And when we're looking at the width here, so if I'm kind of looking at this kind of general width of it, it really isn't much different than the width there. So this would also be moderate. And I'm not seeing a lot of curves, so it's also linear. And I'm not seeing a lot of outliers. So this is a moderate, positive, linear association. Okay, so our third one looks kind of crazy, because if I wasn't looking at this part over here, I wouldn't be able to tell if it's a positive or negative association. It doesn't really look like it's going up, and it doesn't really look like it's going down. But this over here gives us an idea that it's going down. But look how far spread apart that is to be going down. That is really far spread apart. So this is a weak. And because of this part over here, it gives us an idea that it's going down, negative. And I don't really see much of a curve. You could probably say there's a curve, but I still think it's pretty linear. So this is a weak, negative, linear association. Now, as we move farther on, we're actually going to put some numbers to what's weak, what's moderate, what's strong association, as we start talking about what do you call this idea of how close it comes to forming a straight line. Okay, so on our next one, we've got this graph, which definitely looks like it's going up. So we've got a positive association, and then we have, it doesn't look very wide, so I'd probably say this is strong. And it kind of looks like it curves. So this is a strong, positive, curved association. Now our very last chapter, chapter 12 in our textbook, deals with what happens when it is curved. Because most of the time in this chapter we're saying, we don't deal with curved stuff. We're always dealing with linear. But later on, we're going to talk about what if it is curved. How do I deal with it then? Now our next one does not have a lot of points at all. So when we're looking at it, we've got a point here, a point here. Almost looks parabolic. But there's just not really a lot of points. So it's really hard to kind of tell. But it almost looks like you could have a continuous curve. So I would call this a strong, curved, and it goes down and then it goes up. I'm going to say that it's usually positive association. Now, if you were to look at it like these points are like close enough that it's not a big deal, but this point is definitely an outlier. It is kind of away sideways, not a lot, but it's definitely way above. Where this one kind of shows a trend coming up to this one's just really kind of out here. There's nothing like in between here to help out with that. So I would call this an outlier. If it was way more to the side, like left or right, then it would be an influential point. But this is really kind of high above, and I'd call that an outlier. Okay, so in our next one, I can't tell if that is going up or down. So this is really kind of up to interpretation on this one. You can't really tell either way. I guess you could make a case for going kind of down. Or I guess you could kind of make a case for going up like this, but it'd be so wide. So this is definitely weak because you have a hard time really telling the direction. I'm going to go with negative association, mainly because if I were to go side to side, that width, if I go up, this width for going up is really big. But if I go down, this width is much smaller. So that kind of gives me an idea of kind of where to go with that for our negative association. And I'm not seeing a lot of curves, so it's linear. And I've got this weird point out here that is a possible outlier. And he's not really an outlier because he's not really high or low compared to the others, but he is pretty far off to the side. So he's probably more of an influential point. And so these are just different ways we describe that. So when we are looking at you describing what's happening with the scatter plot, these are the things we're looking for. And this is probably the part that's most often forgotten because we get so bogged down in the math later on and the interpretation of our regression lines and stuff that we forget about how to actually describe these patterns. Okay, and that's it for 3.1. Next time we're going to go ahead and talk about that whole strong, weak, and moderate for how close does it come to forming a curve or a line.